This is going to be the most important lecture of this course, Certification Machines. Ending is the meat of subnetting. Fear not, you are in good hands. Let's get to it. First, ending is just lining up every bit of the IP address to a corresponding bit of the subnet mask to find out which range of IP addresses or subnet mask that IP address belongs to. The easiest way to end is to convert the IP address and subnet mask into binary and put them over each other, as you can see on the bottom of the page. From here, you just have one rule to follow. If the corresponding IP address and subnet bit are both 1, then carry that one down to your network address. That is the only combination where you will carry the 1 value down. Anything else is automatically a 0. Every time that you end, the host portion of the subnet mask will be all zeros, canceling out the host portion of the IP address that you are working with and only leaving you the network address. You have basically done this already in the previous pages. Default subnet masks are the easiest to work with. As you can see in the example problem, a Class C default subnet mask is being used, automatically eliminating the last octet of whatever IP address you are working with. The easiest way to read this is to look at the IP address and subnet mask as a pair. The subnet mask lets you know which octet you can modify for the range of host. In this one, when they give you the IP address that ends with .33 and that Class C subnet mask, you automatically know that that subnet is going to be starting with 0 and ending with 255. After that, you just have to line up all your 1s to get the network address. But a trick with default subnet mask is just to line up the octets. So if you look over here on the right side of the screen, we have 255, which carries down the 192, 255, and the second octet, which carries down the 100. We have 255 in the third octet, which carries down the 10, and then the last octet is a 0, meaning that we get rid of the 33. You have basically done this in the previous pages, so let's move on to the next page here. Ending with custom subnet masks is what you have to get fast at. It is very rare that you will run into default subnet masks on certifications and interviews. Remember in the first video when I said that you can use the zeros at the end of a subnet mask to create more network ranges? This is called borrowing bits. Let's read through the first paragraph of this page together. When you take a single network such as 192.100.10.0 and divide it into 5 smaller networks, 192.100.10.16, and then the next ones will be the same except for the last octet, which ends in 32, 48, 64, and then 80. The outside world still sees the network as 192.100.10.0, but the internal computers and routers see 5 smaller subnetworks, each independent of the other. This can only be accomplished by using a custom subnet mask. A custom subnet mask borrows bits from the host portion of the address to create a subnetwork address between the network and the host portion of an IP address. In this example, each range has 14 usable addresses in it. The computer must still add the IP address against the custom subnet mask to see what the network portion is and which subnetwork it belongs to. In this example, we start off with the Class C network. The last octet is called the interesting octet because it is the octet where we will be doing all of our work. It is also the only octet that has both the network. The interesting octet in the example has 8 bits for you to work with since it is the default Class C range. However many bits you borrow, just square 2 by that number to get the number of subnets. In the example, they borrow 4 bits to divide the giant default subnet mask into 16 smaller ones. Now, how do you know the range of IP addresses for each subnetwork? All that you're going to do is use the decimal value of the last subnetwork bit that you borrow. We're going to go back to our basics. Since they borrowed 4 bits in the example, the 4th bit value has a decimal value of 16. As you can see in the center of the table. The center of the page here shows us that our subnets will be in blocks of 16. The first subnet's network address always starts with 0, and the last IP address of that range will be 1 less than your increment value, in this case 15. As you can see on the left, the last octet increments by 16, and on the right, the last IP address of the range is one less than the start of the next subnet. Don't worry, we'll practice this a ton throughout the rest of the lectures. Thank you for making it this far, and I will see you in the next lecture.